This video is about simplifying using the law of exponents. So before we get into our laws of exponents for the day, let's talk about an idea where we have a number raised to a power. So what does 2 to the 8th represent? So remember that 8 is our exponent and 2 is our base. So if we have 2 to the 8th, that's really 2 times itself 8 times. So 2 times 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 2. So we can multiply it out all by hand, or in our calculator, we can just do 2 to the power of 8, which in this case is equal to 256. Remember when you're evaluating, if a number is more than 4 digits, we're going to leave it in exponent form. So let's look at some multiplication properties of exponents today. So the first one that we have is the product of powers. So with the product of powers, when multiplying powers that have the same base, you add the exponents and the base does not change. So for a general example here, we have a base of a and a base of a, so we would add the two exponents together. So in this case, we have 2 to the first power if there's no exponent times 2 to the 5th. So we would add those exponents together and get 2 to the 6th. So let's use this idea on a couple of these problems. So number 1, we have 5 to the 7g times 5 to the 2g. So 5 is going to stay as our base, and we're going to add our exponents. 7g plus 2g, which gets us 5 to the 9g. Number 2, v times v to the 12th. So remember, if we just have a v, it has an exponent of 1. So our base is v. We have 1 plus 12, which gets us v to the 13th. Number 3, now we have 3 bases that are all the same. They're all f. So we're going to have f to the 9 plus negative 5 plus 2. So 9 plus negative 5 plus 2 gets us f to the 6th. Number 4, all of our bases are the same. Again, they're negative 2, so we're going to add our exponents. We have negative 2. Make sure that you leave it in parentheses if it started in parentheses, and add your exponents. 2a plus 11a plus 6a. So 2 plus 11 plus 6 would get us 19a. Now, number 5, notice that we have these numbers here. We have 5 and 3. If we have numbers that do not have exponents, they're going to get multiplied together. So 5 times 3 is 15. And then we're going to add our exponents, get 12 plus 20 gets us 15g to the 32nd power. In number 6, notice that we have 3 numbers without exponents, 2, 4, and another 2. Now, even though they're not in front of the same variable, they can all be multiplied together still. So 2 times 4 times 2 gets us 16. Then we have a base that's an x to the negative 2 and x to the 8th. Those are going to get added together, so we have x to the negative 2 plus 8. And then y, there's only one of them, so it's going to stay as y to the 6th. So when I combine my exponents by adding them, I get 16 x to the 6th, y to the 6th. Now, x and y are not going to combine together because they're two different variables. Number 7, we have negative 3 to the 4v times 5 to the 13w times 5 to the 8w times negative 3 to the 3v. So we have two different bases again. We have a negative 3 base that's going to combine together. So negative 3 in parentheses, 4v plus 3v. And we also have 5 to the 13w plus 8w. So when I combine my exponents with the addition, I get negative 3 to the 7v and 5 to the 21w. Those are two different bases, so they don't combine together. Number 8. So when I look at number 8, I see numbers, again, that do not have an exponent. 3, 10, and 5. So 3 times 10 times 5. Remember, coefficients are going to be multiplied, so we get 150. Then I'm going to combine my m. So I have m to the negative 3, m to the 8th, and just m. So I get negative 3 plus 8 plus 1. And then I have k's to the 12th plus 14. So when I combine my exponents in this case, I get 150 m to the negative 3 plus 8 is 5, plus 1 is 6, and k to the 26th. Now, another property that involves exponents and multiplication is a power of powers. So when you have one base raised to 2 powers, you are going to multiply the exponents, but the base again does not change. So for example, we have 3 to the 4th in parentheses raised to the 5th power, so we're going to multiply 4 times 5, and we get 3 to the 20th. So in number 9, this becomes 3 to the 3 times 5, which is 3 to the 15th. Number 10, we get c to the 9 times 3g, which becomes c to the 27th g. And number 11, be careful. Now, this negative x is already in parentheses, so we're going to keep the parentheses around the negative x to the 4 times 4. So we get negative x to the 16th power. Our last exponent property today, then, is the power of a product. So if you have things being multiplied in the parenthesis, we're still going to multiply the exponents. This time we're going to multiply both exponents. So in number 12, we have a 3 exponent on the outside. So everything is going to get multiplied by a 3 exponent. So we have j to the 3 times 3, k to the 11 times 3, and m to the 5 times 3, which simplifies to j to the 9th, k to the 33rd, and m to the 15th. Number 16. Here's where you got to be careful with 16. Notice that 5 right now doesn't have an exponent, but there's an exponent outside the parentheses, so remember that 5 really has an exponent of 1. So this becomes 5 to the 1 times 10, a to the 9z times 10, b to the 2y times 10, and c to the 5x times 10. So this simplifies to 5 to the 10th, a to the 90z, b to the 20y, and c to the 50x. Now, if I put 5 to the 10th in my calculator, 5 to the power of 10, I get a number that's bigger than 4 digits, so I'm going to simplify and just leave it as 5 to the 10th. I'm not going to worry about using the exponent and getting a number. I'm just going to leave it as 5 to the 10th. So let's do some mixed practice problems. So number 14, we have 7 to the 4th and 3f on the outside. So because this is a parentheses, we need to be multiplying our exponents. So 7 to the 4 times 3f gets us 7 to the 12f. Number 15, all of these have the same base of f. Remember that this middle f has an exponent of 1. So when they all have the same base and no parentheses, this is where we add our exponents. So f to the 9 plus 1 plus 4. 9 plus 1 plus 4 gets us f to the 14th. Number 16, we have an exponent of 6. Remember that this 5 again has an exponent of 1. So because there's multiple things in the parentheses, each thing is going to be multiplied by 6. So we have 5 to the 1 times 6, x to the 3 times 6, y to the 2 times 6, and z to the 4 times 6. So 1 times 6 gets us 5 to the 6th, x to the 18th, y to the 12th, and z to the 24th. If I put 5 to the power of 6 into the calculator, it's bigger than 4 decimals, so we're going to leave it as just 5 to the 6th. Number 17, I have negative 1 as my base for all these, so I'm going to put negative 1 in parentheses. I'm going to add my exponents because there's multiple bases. So 8 plus negative 5 plus 7 gets us negative 1 to the 10th. Now, negative 1 to the 10th is a number, so we can try evaluating that out. So negative 1 to the power of 10 is just 1. 18. There's two numbers out front, so we can multiply those together since they do not have exponents. So 5 times 20 is 100. And then we're going to add our exponents with the w's. So 3c plus 14c, that gets us 100 w to the 17th c. Number 19, same idea again. We have numbers that we can multiply, 5, 3, and negative 5. So 5 times 3 times negative 5 is negative 75. There's two bases in this case. There's an x, so we have x to the 21 plus negative 10. And there's only one y, so it's going to be untouched, and it stays as y to the 8th. So when I simplify this then, I'm going to get negative 75 x to the 11th, y to the 8th. Number 20. Now, there's a set of parentheses in number 20, so before I can do anything else, I need to multiply everything with an exponent of 4. Remember that 2 again doesn't have an exponent, so it's just a 1 there for now. So this becomes 2 to the 1 times 4, x to the 3g times 4, y to the h times 4, times x to the negative 5g, y to the h. So when I simplify this, I get 2 to the 4th, x to the 12g, y to the 4h, times x to the negative 5g, y to the h. Okay, so let's simplify 2 to the 4th first. So 2 to the 4th we know is going to be a number we can evaluate, and we get 16. Then I have two bases that have an x, so I'm going to add those exponents together. 12g plus negative 5g, and same thing with the y's. So I have y to the 4h plus h. So when I simplify then, I get 16 x to the 7g, y to the 5h. Number 21. So looking through number 21, I see a couple coefficients that need to get multiplied together first. I have 2 and negative 4. So 2 times negative 4 is negative 8. Then I have a couple of different bases here. So I have x's, x to the 2 plus 8. I also have y's. One of these y's doesn't have an exponent, so remember it's an exponent of 1. So I have y to the 1 plus 19. And then I have z, which doesn't have a partner, so just z to the 4th. And now I'm going to combine those exponents for each variable. So I get negative 8 x to the 10th, y to the 20th, and z to the 4th. Number 22, now it's starting to mix in some of the things we talked about the day before. So first, let's see, is there any 0 exponents that I can simplify to 1? So I have n to the 0, which is 1 here, and negative 2n in parentheses to the 0. So those things both become 1. So I'm left with n to the 8, n to the 5th, times 3, times 4n to the negative 12th. Now I have three coefficients here. I have negative 8, 3, and 4, which can all be multiplied together. So negative 8 times 3 times 4 gets us negative 96. And then I can combine my n. So I have n to the 5 plus negative 12. That gets me negative 96, n to the negative 7th. Remember from yesterday, we can't have negative exponents, which means this needs to move to my denominator of my fraction. So I'm left with negative 96 over n to the 7th. Number 23. We have two negative exponents, so let's move those first. Both negative exponents are going to move to the numerator of my fraction. And I can also reduce 4 and 8. So let's do that first. 4/8 reduces to 1/2. And then we have n to the 14th, y to the 15th, n to the 5th, y to the 8th. I can combine things that have the same exponents. So both n's can get added together, n to the 19th. Both y's can get added together, so 15 plus 8 is 23. And we're going to leave our 2 in the denominator. You can put a 1 in the numerator if you want, but it's not required. 24. First thing we need to do is we need to multiply our exponents inside the parenthesis. So remember, everything gets multiplied by -2 in the exponent. So we have -3 to the 1 times -2, a to the 3 times -2. In my other set of parentheses, I have 2 to the 4th, x to the 7 times 4, and y to the 4th. So let's first simplify this. So we get 3 to the we get -3. Let's put -3 in parentheses. So -3 squared, a to the -6 times 2 to the 4th, x to the 28th, y to the 4th. Now, there are no bases to combine, but I have negative exponents that need to move to my denominator, because I have a negative exponent for a and a negative exponent for -3. So we get 2 to the 4th, x to the 28th, y to the 4th, all over -3 squared, a to the 6th. Last thing I want to do is I want to simplify this. So 2 to the 4th, remember from earlier, is 16. X to the 28th, y to the 4th. -3 squared, make sure you're using parentheses. So -3 parentheses squared is 9, a to the 6th. Our last problem, let's first look and see, do we have any x's or exponents of 0? So we have x to the 0, and we're going to multiply everything in our parentheses by an exponent of 4. So we now have -2 times x, y to the 5th, times -3 to the 4th, x to the 4 times 4, y to the 3 times 4, all over x to the -4th. So this simplifies to 2 times x, y to the 5th, times -3 to the 4th, x to the 16th, y to the 12th. Also notice that this x to the 4th was negative, so we're going to move it to our denominator and add it at the end here, x to the 4th. So when I combine things, first let's simplify -3 to the 4th is 81. So we now have -2 times 81 times, let's look at our x's. So we have an x to the 16th, and an x to the 4th. So that gets us x to the 1 plus 16 plus 4. And our y's, we have a y to the 5th and a y to the 12th. So I'm going to simplify this. So 2 times 81 is -162. Add this together, I get x to the 21st and y to the 17th.